Welcome back, everybody. This is our fourth video in the JEE mains previous year questions for class 12th of chapter atoms. Before this, there are three videos available, and all of those are available on our channel's playlist section. And we have similar series for NEET also. So if some of your friends are preparing, you can guide them through those videos. If you like these videos, then do press the like button, share them, subscribe to our channel, like to support us financially, scan the QR codes in front of your screen. With this, let's start today's video. Here in the previous one, we covered up to this question number up to 26. And today we will move or start with question number 27. So according to Bohr's theory, the time average magnetic field at the center, it means the nucleus of hydrogen atom, due to motion of electron in the nth orbit, is proportional to where n is the principal quantum number. Now we know that suppose if we have a coil, suppose this is a coil, then magnetic field at the center of this coil is mu node n I by twice of the radius, where n is the number of turns in this coil. So, and pardon me for one thing, n is already denoted for the orbit, means this orbit, the orbit number is n, so I cannot use n here. I have to use some another variable, let's say m. So mu node m. So what is m? M is number of what can I say, number of turns in coil. Now in case of electronic orbit, there is only one orbit, so we can say m is 1. So m is going to be 1. So magnetic field will be mu node I by twice times the r. Now this r is the radius of this orbit, and if it is nth orbit, then radius of nth orbit will be r. N is equal to n squared times r node, where r node is the radius of first orbit. So magnetic field due to nth orbit will be equal to mu node I by twice r node into n square. And from this I can write that magnetic field due to nth orbit is proportional to 1 by n square, where n is the orbital number. So that is option D for us. Now, this question can be further solved by a different method, and I will encourage you to use that one. Why? Because it is also useful in some other questions where we have to find magnetic dipole moment or angular momentum, like these things. So this concept is based on the gyromagnetic ratio. So for any charge particle, whatever the shape may it have, whatever the charge it may have, if it is rotating, then ratio to its magnetic dipole moment to angular momentum is always constant, and it is E by 2m, where E is the charge, m is the mass. So, and here mu is magnetic dipole moment. Magnetic dipole moment, and L is angular momentum. So we know that angular momentum is L is basically distance into linear momentum. So distance for like this is suppose electron in nth orbit. So distance from the center is Rn. So its angular momentum will be Rn into its momentum, that is m into v, where v is the basically velocity. And coming to the magnetic dipole moment is basically flux B dot A. Okay, I think I wrongly interpreted as magnetic moment as B dot A. That is basically flux. That is magnetic flux. So I think this method is not going to work here. This method is not going to work here. So we have to use this method. So pardon me for that. And we have already solved by this method. I was thinking that I can have another method, but in mu I don't have any method to get magnetic field that easily. So we have to stick with that normal coil method, that for a circular coil using magnetic field or circular coil. So let's move to the next one. So a hydrogen atom makes a transition from N2 to N1 and emits a photon. This photon strikes a doubly ionized helium atom and in excited state and completely removes the orbiting electron. The least quantum number for the excited state of the ion for this process. Now we have a hydrogen atom which is making transition from second to first level. Now for hydrogen atom we know that energy of the second atom second level is minus 3.4 electron volt and of the first level is minus 13.6 electron volt, and their energy gap, that delta E, is basically 10.2 electron volt. So this is the energy of the photon. Now as mentioned, that this photon strikes the lithium doubly ionized lithium atom, means it is basically it will behave like a hydrogen atom, and Bohr's model is applicable here, and it completely removes the electron. Means if it is completely removing the electron, means what we have here, we have ionization. We have ionization here, and for ionization that electron has to be in an orbit where its energy is exactly minus 10.2 electron volt or less. Because in case of ionization, suppose this is the nucleus and this is an electron, and its total energy is suppose say minus x electron volt. So if we provide it, we strike a photon of x electron volt on this electron, so what will happen? We will have ionization, and the electron velocity after ejection will be 0. But if this photon has some additional kinetic energy, additional energy, let's say x plus 1 electron volt. So if there is ionization is happening, then this electron will come out with kinetic energy of 1 electron volt. That additional energy will appear in the form of kinetic energy. So here it is not mentioned that it is coming with velocity or not, but in the later part it is mentioned least quantum number, means we assume that it is coming with velocity 0. It is coming outside with 0 velocity. So let's start with calculating the energy levels of lithium atom. So for lithium, what we will have, En will be equal to minus 13.6 into Z, that is 3, so 9 divided by N square. Now we want this to be equal to minus 10.2 electron volt. And if we solve this one, what we will get N square is 136 by 102 into 9. Now if we solve this, from this we will get N is equal to 3.56 or 45. Yeah, 3.46. But we know that this N represents an orbit, and this cannot be a floating point. Oh, sorry, not floating. Means it has to be integer. It cannot be a floating point or decimal number. Means there is no level in lithium, this doubly ionized lithium atom, which has the energy equal to 10.2 electron volt in negative terms. So means there are two possible scenarios, or from this what we conclude, that electron will come out with non-zero velocity. This was the case where we equated both of these, which meant that electron is absorbing all of the energy and it is coming out with zero velocity. There is no energy transferred in the form of kinetic energy. But after calculation, we are getting it as floating point number, means it is not possible. So electron will have non-zero velocity. So for non-zero velocity, we have to compute each level independently. Now we cannot use the formula, and actually answer will be 4 because fourth level will have the energy slightly lower than this 10.2. So let's calculate for the third level. First, for the third level, that will be minus 13.6 into 9. Now n is 3, so 3 square is 9. So for third level, we have energy minus 13.6 electron volt. For the fourth level, we will have minus 13.6 into 9 by 16. And this will give us, we will get negative 7.65 electron volt. So electron in this orbit, in the fourth orbit, can absorb a photon of 10.2 electron volt and can get ionized. It can get ionized and it will come out with kinetic energy of 10.2 minus 7.65. And if I calculate, this is 5, 11 minus 6, that is again 5, yeah, and 9 minus 2, 2.5. So it will come out with kinetic energy of 2.55 electron volt. So this is the case of ionization. Now keep in mind that in case of ionization, the photon is completely absorbed, but its energy does not need to be equal to the energy gap. That only happens in case of excitation. Let me discuss that one also. So hopefully it will clear your mind if you have any doubts between excitation and ionization. So I am now discussing the same case if we had excitation. Now for excitation, the energy gap between lithium 2 positive ion levels should be exactly equal to energy of photon. Means, what does it mean? So let me show it. So first level of lithium has an energy of minus 13.6 multiply 9, that is negative 122.4 electron volt. Now for the second one, it is 30.6 minus 30.6 electron volt. For the third one, we have already solved, that is minus 13.6 electron volt. For the fourth one, it is minus 7.65 electron volt. For the fifth one, it will be divided by 25, that is 4.89 electron volt negative. And let's take one more, E6, that will be divided by 36. So that is minus 3.4 electron volt. Now, as mentioned, we are now discussing the case of excitation, and our photon has an energy of 10.2 electron volt, and we can clearly see that these two levels have exactly gap equal to 10.2 electron volt. So if it is mentioned that excitation is happening, then electron will be excited from the third level to the sixth level. So for excitation to happen, electron will transit from third to sixth level, or second excited state to fifth excited state. This is for excitation. But for ionization, this electron in the third orbit cannot absorb 10.2 electron volt photon and get ionized because energy is less. But if electron in the fourth level or in the fourth orbit can absorb electron of 10.2 electron volt and get ionized, it will have some kinetic energy that we have already calculated. Similarly, electron in the fifth orbit can do this the same. Electron in the sixth orbit can do the same, and seventh, eighth, and so on. They can all get ionized by absorbing the electron of 10.2 electron volt. The only difference will be their final kinetic energy. The higher the number, more the final kinetic energy they will have. Now, let's come back to the question. As per mention, the least quantum number of the excited state for this ion for the process is, and the process here is completely removal, means ionization, And we have solved that for that ionization to happen, electron must be in the fourth state. Electron must be in the fourth level, and that is fourth level means third level 4 means third excited state, and that is the ask here, that in from which excited state it will happen. So atom has to be in the third excited state. So option D is the right answer here. I hope it will be clear to you. Now with this, let's start to the next one. As an electron makes a transition from excited state to the ground state of a hydrogen-like atom ion, kinetic energy, potential energy, and total energy we have to find out. So we know that it is for hydrogen-like ion it is asked. So for hydrogen-like ion, total energy of the nth state is minus 13.6 into Z square by N square electron volt. Now coming to the kinetic energy, it is just modulus of this, so it will be 13.6 Z square N square electron volt. And potential energy, it will be twice of the total energy, so that will be minus 27.2 Z square N square electron volt. Now let us assume Z is 1, so then total energy becomes for nth level minus 13.6 N square electron volt. Kinetic energy 13.6 by N square electron volt. And coming to the potential energy, that is 27.2 in negative by N square electron volt. So now coming to the question, electrons make a transition from excited state to the ground state. So it is moving from higher number of n, or it is moving from n to 1. So what we can see here, that value of n is reducing. If n is reducing, then what will happen? Magnitude of this term will increase. Magnitude of 13.6 by n square will increase, but it is increasing in negative. So actually this is decreasing. So total energy will decrease. Now same will happen with potential energy. As value of n decreases, this value of n decreases, so magnitude increases, but there is a negative sign, so this term will reduce further. So total energy and potential energy is decreasing, but for the kinetic energy, here magnitude of this term will increase, and this is a positive term, so kinetic energy increases, but potential energy and total energy decreases. So that is option C for us. Let's move to the next one. The de Broglie wavelength associated with the electron in the n is equal to 4 level is. So we have just solved it, I think 2 or 3 times, that de Broglie wavelength of the nth level is equal to n times the de Broglie wavelength of the ground state. So it is for the fourth level, it is 4 times the de Broglie wavelength of the ground state. That is option B for us. Now let us move to the next one. 31. If one were to apply Bohr model to a particle of mass m charge curve moving in the plane under the influence of a magnetic field P, total energy of the charge particle in the nth level will be. So in this question, we have to find out the energy of the charge particle. So before solving this question, we have to make some assumption. Now we know that total energy that is asked in this question is basically sum of kinetic energy plus potential energy. So kinetic energy, we know that is basically half mv square. So we have to compute this term. Then we have to convert it into one of the form given here. And coming to the potential energy for in the magnetic fields, potential energy will be minus mu dot B, where mu is the magnetic dipole moment of the moving charge and B is the applied magnetic field, which is B already given here. Now what we are going to do here, we will assume that suppose this is the plane and our charge particle is moving in circle like this. So normally in these type of questions, we don't assume any we can say or normally in this type of question, what we do, we ignore the value of mu, or we assume that mu is such a small value that its product with B will be negligible. In case of normally in the case of questions related to magnetic field, we generally ignore potential energy value. Yes, you can compute it, and that will be the that will be actually the right answer. But normally in these type of questions, potential energy is ignored, and that is what we are going to do here. And after solving this one, I will give you a hint that means I will do approximate calculation that how we can also calculate this potential energy if you are interested in calculating it. So first of all, let's move to kinetic energy only. Now we have discussed cases of cyclotron where there is a charge particle magnetic field applied, then it moves in circle. So for that type of particle, what we have, the radius is equal to mv by qb. That is the radius of the moving charge particle. So from this, we can write mv is equal to qbr. And from this, we can further write that mv square is qbr times v. And we also know that velocity from this expression, that will be qbr by m. So if I substitute it here, then I will have mv square is equal to q square b square r square by n. Now if I multiply half here and half here, so this will be equal to just kinetic energy. So we have the basic setup for kinetic energy. Now, in case of charged particle moving inside a magnetic field, there is a Lorentz force applicable on it, and that force is QVB, Q into V cross B, and that should be equal to the centripetal force, that is mv square by r. And also, as mentioned, that Bohr model is applicable here. So in Bohr model, what we have? We have conservation of angular momentum, and that is given by that nh by 2 pi is equal to angular momentum, that is mvr, and here we will have nvrn. Now if I multiply both of these equations with each other, so what I will get nh by 2 pi into qvb is equal to m square v cube, and basically r will get cancelled. Now we can cancel v from here, so it will be square, and okay, m cannot be cancelled. So this is we have nhqb by 2 pi is equal to m square v square. Now from this I can write further that mv square is equal to nhqb by 2 pi m, and from this half mv square will be nhqb by 4 pi m. So nhqb by 4 pi m, that is our option C. We could not get it via this method, so we moved via second one. So now coming to the potential energy term, that how we will calculate the potential energy. So as mentioned here, that Bohr model is applicable, and that charge particle is in the nth level. Bohr model is applicable. Charge particle is in the nth level. So let me draw the plane again. So this is our plane. This is a charge particle moving in a circle in the nth level. So first of all, magnetic moment is I into A, current into area. So if it is moving in the nth level, it will be making some, let's say, m revolutions per second. It will be taking m revolutions per second. Then this mu will be, this m will act as number of turns. So this will become mu times A times area, that will be pi times Rn square. And as Bohr model is applicable, means like hydrogen atom, we can write Rn is equal to R naught times n square. And okay, I forgot m here, so m will also be there. So that is it, m pi I R1 square. So this becomes m into n raised to power 4 into current into pi into R naught square. This is mu. Now coming to the this is mu. Now coming to the magnetic potential energy, that will be minus mu dot B, where B is the magnetic field. So this term will be mn4 I pi R naught square B. Now we can see here that this includes lot of unknown terms. So lot of terms which are not easily known to us, and it's quite difficult to calculate. That's why we ignore potential energy in terms of magnetic questions related to magnetic field. That's why these are ignored. So hopefully from the first part it will be clear to you. And with this, let's move to the next one question. The radiation corresponding from 3 to 2 transition of a hydrogen atom falls on a metal surface to produce photoelectrons. These electrons are made to enter a magnetic field of 3 × 10⁻⁴ Tesla. If the radius of the largest circular path followed by these electrons is 10 mm, the work function of the metal close to. So radius is given to us. So from the radius, what we can do, from the radius, that is 10 mm, so 10 into 10⁻³ meters. Value of magnetic field is given 3 into 10⁻⁴ Tesla. So we just have calculated the formula of kinetic energy, half mv square, in the previous question. Here it is. It was q square b square r square by 2m. So it is q square b square r square by 2m. So from this we can calculate the maximum kinetic energy, and it will be half. Charge is 1.6 10⁻⁻19 and whole square for electron. Magnetic field square will be 9 into 10⁻⁻8, and radius, that will be 10⁻², so 10⁻⁻4 divided by mass, that is 9.11 10⁻⁻31 for electrons. And what we want to do, we want to calculate it in terms of electron volt. So we will further divide it by 1.6 10⁻⁻19. So when we solve this, we will kinetic energy as 0.79 electron volt. Now coming to the electronic transition, which is happening between third and second level of hydrogen atom. So we know that energy of the third level for hydrogen atom is minus 1.51 electron volt, and for the second level it is minus 3.4 electron volt. So from this, the energy of the emitted photon, delta E, that one will be equal to difference of both of these, and that is 1.89 electron volt. Now for photoelectric effect, we know that maximum kinetic energy of ejected electron will be equal to E minus phi. So here we have maximum kinetic energy as 0.79 electron volt. Energy of the incident photon 1.89 electron volt minus phi, and from this we can calculate that phi will be equal to 1.1 electron volt. That is equal to option B for us. So option B is the right answer here. Hopefully you understood it well. And with this we end this video here. If you have any doubts, suggestion, put them in comment section. Like this video, then share it, subscribe to the channel, and want to donate us something, scan the QR code. With this again, thanks for watching, and we will meet in next video.